Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Okay, so for our first podcast, we're going to talk about our experiences with Kotlin.
Yes.
And you've been using it for about a year through, it's like something obviously that Google is using a lot, but what got you involved with it? What drew you in?
I was doing Java a long time ago.
Sure.
And then moved to Scala and spent a lot of time trying to learn Scala. And I love Scala and use it when I can now. Mm-hmm. But Scala, I think, is while I love it and it's my favorite, I don't think that Scala is necessarily worth it for most Java developers who are looking to take some steps forward in a programming language. And so I started learning Kotlin to see, is this viably a better path forward for Java developers? And after having used it for a year now, I think absolutely there's so many great things in there for Java developers. So that's why I started exploring it.
Yeah.
And I've built a number of things with it now.
Oh yeah. Yeah. Well, I mean, I'm surprised because I feel like I sort of got pulled into it. I'm not even, it's a little hazy now, but I thought, oh, well, it'll be like when I wrote Thinking in Java. I'll write this book on Kotlin and it'll be interesting. I won't actually use it, just like I don't actually use Java for anything. Yeah. But it started just creeping in and I started noticing how many, and their philosophy is steal all the good features from that work, not just the good ideas that are proven to work in other languages. And they just kept doing that. And it's really gotten to where I'm actually starting to reach for it versus Python, which has been my go-to for if I need to solve any of my own problems. But I'm kind of creeping, Python's still great and still really enjoy that. But there are a lot of things where I'm going, I could do that in Kotlin and it wouldn't be painful like it would be in Java.
Yeah. And you've been writing a book on Kotlin, so you've been digging deep.
For 3 years now. We're almost done. I'm on the
How long have you been saying almost done for?
I'm pretty careful about saying that kind of thing. We have the early access edition up, and that's at if you go to atomickotlin.com, you can see it. And that I said it was 80% done. It was probably more, but I wanted to be a little conservative.
Yeah.
So, but I am working on not the last chapter in the book, but the final chapter because it was a hard one. It's on creating generics. So, but even the generics.
Variants it's tricky.
It is because you have to understand what the problem you're because, and it's still, I haven't gotten the whole clarity of it, to the point where I can explain it to somebody and they go, oh, I see what you're talking about. Because initially you want to go, well, it's really about upcasting. So if you have a list of pets and you upcast it to a list of animals, well, that's not really upcasting, though. You're assigning a list to a list.
Right.
It's what it holds that makes the variance an issue.
Well, and it depends on if it's in or out, which I think Kotlin did a good job of distinguishing the difference between in and out. Because you want different variants, whether it's coming in or going out. Mm-hmm. And that made sense to me, but I don't totally remember why.
Yeah, well, because when you say something is in, that means that the methods, the member functions, they call them in Kotlin, can accept arguments of that type.
Oh, and you want them to be able to be more specific when they come in and less specific when they come out. Like you want to be able to pass in a list of dog to something that takes a list of animal. But then when it comes out, you don't want it to be a list of dog. You want it to be that list of animal, right?
Right. Yeah. So the in and out is actually a much better mapping. And I'm not sure if they picked it. I wonder if they picked that up from like TypeScript or something.
Yeah, I don't know where,
because I know
I hadn't
that
seen that
they went
really
everywhere
specified in that way
to get
before.
features, and some of them were just, like in Java, there were just some idiotic decisions made because they were in a hurry or something like that. Like there was no need for the new keyword in Java, because in C++, new distinguishes, am I creating it on the heap versus creating it on the stack? In Java, you create everything on the stack, so you don't need the new keyword, but they didn't think of that or know it or understand it or something. There's so many things that
yeah,
the original Java designers didn't understand when they were doing important language design.
Yeah.
So
in Scala, they have it's covariant, contravariant, invariant.
Oh, they actually have those keywords?
No, they use like pluses and minuses, and I can never remember.
Right.
But what's interesting is that I think very typically you want something to be, I don't know, covariant coming in and contravariant coming out or whatever it is.
Mm-hmm.
And I can never remember. So I just, try stuff and the compiler tells me basically what to do.
Or the IDE.
Or the IDE.
Yes, that's way. I have to say one of the things that has happened in this process, because initially I was using Sublime Text, and I still use it for some things. But then finally, it wasn't until like December or whatever, I finally started using IntelliJ.
Oh.
And it was like, oh my God. Why haven't I been using this the whole time? Because it does so much for you. My friend Luciano Ramallo, who's wrote Fluent Python, I was saying, oh, you have to try PyCharm for Python. He goes, oh, no. I go, really, give it a try. You'll see, because it does things for you.
Yeah.
That's the key, how much it does. And it's like, rather than hunting around looking stuff up, you just... it's
IntelliJ has definitely become a very integral part of my development cycle, because the first thing I do when I'm writing code is get rid of the red squigglies.
Sure.
And then there's going to be some warnings or, some hints, that kind of thing, that I try to get rid of as well. But then the compiler, when it runs, hopefully by the time the compiler runs, like, it should just compile, because IntelliJ has helped me get there.
Right.
My like most inner dev loop is IntelliJ and all the things it's doing for me. And then the compiler is kind of that second tier loop. And then my tests are kind of the third tier.
And the little light bulbs that come up for you, like you can see, because I've started doing things like going, I wonder what type I've just created. And you can do the thing where it says, put down the explicit type. That's super helpful.
There's so many things that make my life easier.
It is an amazing tool. So I saw a survey the other day about what people like the most about Kotlin. And like far and above everything is the handling of nulls.
Yeah.
Making sure that you don't have null problems.
Yep. Yeah, I've had that in Scala with option and other structures. The nullability, the syntax in Kotlin for dealing with nullability is really nice. Where I get a little bit tripped up on it is that there's some things that are lost from the way that I dealt with it in Scala. So as an example, it's kind of hard to do chaining of nullable things. And so let's say that you have a nullable thing that you're going to get a key out of, and then you want to go look into a set for that key, and that also can be nullable. So you've got like this nullable chaining that you want to perform, and not the dot syntax. Like that part is great with the question mark nullability operator, but more like I've got two separate data structures, and I need to use the thing that might come out of the first one to get something out of the second one, which can also be nullable, and then be able to like chain those things together. And when you're using option, it's super easy because option's a monad, but I'll try not to say that M word on our podcast, but it's super easy to do that kind of thing when you have monads. And with the nullability operator, it takes a bit more work to do that kind of thing. So
Mm-hmm.
So there's so many great things about it and how easy it is to avoid null issues, but there are some things that I miss from the Scala days.
Yeah,
syntax.
so it took me a while to understand that their model is, rather than throw an exception, return a null.
Yeah,
which is like, I can kind of see why they made that choice, because if you don't and you want to be able to, do this, your next step may be monads.
Yeah.
And they're like, I came across an article.
Always a slippery slope to monads.
Yeah, it seems like it. And I can see they go, that's too much to load on to people. So we'll say, we'll return the value or return null, and then you can use these, various operations to deal with that. But
and so much of their value is around interop with Java, and
yes,
there's so many Java libraries that return null. So
it feels like being because I was on the C++ committee for its first 8 years, and that was so dominant, and people talk about C++ being a badly designed language, and I can categorically state it was not. It was very carefully designed, but it had this constraint of backwards compatibility with C, which just caused all kinds of struggles.
And only we could always start fresh.
Yeah. And I feel like what Kotlin's been able to do with its compatibility with Java is really, it's quite brilliant in many ways, because
like extension functions on Java objects like that.
Yeah.
It's a cornerstone.
When I first saw extension functions, I thought, this is just, syntactic sugar. This is not, I don't really see that. But then when
it changes the way you program, and you're like, whoa.
It does. It changes the way you program. It changes the way you think about inheritance, for sure. Because you go, inheritance to add functionality. No, why would you do that? You would just, and then the ability for an extension function to work with a lot of different types is fascinating. But in particular with Java.
Generics combined with extension functions.
Yes. Well, and also the
function
extension lambdas.
Yeah, extension lambdas.
Yeah. Right. That's really interesting. Some of the possibilities that you can do with that.
Yeah.
Yeah. It's, and like when you take a Java class, one of the standard like collections or whatever, and then you put all these extension functions on it, and now you make it into something really useful. But if you have an object of that, you can pass it right back to Java.
Yeah. And
so you get you really get the best of both worlds. I have to say, extension functions are like, never what I thought they would be.
Yeah.
So, and I'm still puzzling. I'm going, why is that such a powerful thing? I don't fully understand it.
I think a big part of it is that we were forced into one model of inheritance, of polymorphism, which was inheritance-based polymorphism, and extension functions gave us another way to do a type of polymorphism, but without having to use inheritance. And there are others as well.
Well, yeah, generics are, there's a name, it's parametric polymorphism. Yes. That's what generics are. Yeah. So you have I think
there's like 4 different types of polymorphism in across different languages, but type classes are kind of a way to achieve some
kind of, and then you start going, well, what do I mean when I say polymorphism, when I say these things? It's like it muddies the water.
Ad hoc polymorphism, I think, is I think extension functions are kind of ad hoc polymorphism.
Okay.
I can't remember.
And Julia uses it has a different way of doing things, because everything is kind of function overloading oriented, and that's using I'm still coming up the curve on Julia. But
I learned via Twitter yesterday that Julia's arrays are 1-based instead of 0-based. And the person that posted it was like, this is kind of a deal breaker for me. But what's interesting is that after reading that, I realized that I don't ever really use numbers for accessing arrays anymore.
No,
because I'm not using like for loops.
You're a functional guy now.
Exactly. So
yeah, so you don't care. Yeah,
I call dot head or dot first in Kotlin, or first or null in Kotlin.
No,
and so I don't care if it's 0-based or 1-based anymore.
No, I feel uncomfortable using numbers to look things up. It feels vulnerable to me.
Yeah.
So yeah, it's a strange thing.
At least with Kotlin, you can look things up based on their index and get a nullable result out.
Right.
So, but if you are using numbers, then you definitely could. I don't know. Everyone knows that things are 0-based except for in Julia, I guess. So hopefully people aren't using 1 to get the first thing, but then have bugs because, anyways, they shouldn't use that.
Yeah, well, Julia is designed for massive amounts of data, and so indexing in by number seems unlikely. But it would be interesting to know why they made that decision. Maybe it's because they're working predominantly for data scientists and things like that. But still, I don't know. That's a curious one.
Yeah.
So what else do you like about
the data classes stuff is really nice.
Yes.
We have something similar in Scala case classes, and so but yeah, generating code to me just always feels so dirty. And
you mean handwriting boilerplate?
Yeah.
Yeah.
Well, and with Java, people will say, "Oh, your IDE generates the getters and setters and equals and hash code and all that kind of stuff." But like, I don't even want to see it. I just like the compiler should generate it for me.
Yeah.
If it needs it, the compiler should generate it.
Yeah.
So the data classes syntax is really nice.
Yeah, and that's propagated to a number of. I mean, Java has it now. I know Python has picked up
in
data.
Java 14 or something.
Is that?
Yeah. Something like that.
And Python picked up. They have a standard decorator for data classes now to do that kind of thing, and it's like everybody sees it's a good idea.
Yeah.
But I don't think they. I mean, Kotlin didn't invent it. I think Kotlin, that's another feature that they stole.
Yeah. Yeah. Oh yeah. Yeah. I saw it first in Scala with classes, but I'm sure somebody else had it before that. So yeah, data classes are awesome. I want to go back to the returning null thing because that is one of the things that's been hard for me in Kotlin is that mentality. Not that you can't do it differently, but a lot of the libraries, like I think exceptions should just die. I hate exceptions. But what that means, and with nullability, what that means is that every function should return something that can either succeed or fail. And then you should be able to take that thing and do what you need to based on that result. This is what's called like bifunctor IO, or if you're doing IO, then we call bifunctor IO. Any kind of effect. I think it's a much better model than the returning null kind of thing.
I think that was a compromise.
But yeah, I think because of Java interop, it does seem like exceptions and throwing and returning null are just, they had to kind of bring that along with them.
There was a article recently by Roman. Did you see it?
Yeah.
Where he said, and what was nice, and I incorporated the descriptions into the book, which because they were saying, okay, if it's something that could fail, it's expected to fail, then you do the null or value.
Yeah.
And then, if it's truly an error, you throw an exception, but you don't catch it at the lowest level, you catch it at the highest level.
Yeah.
And that's almost always IO errors, that was a different category. IO errors, which could throw exceptions, and could actually be recovered from.
Right.
So then you do it at a little higher level, and the mistake in Java was forcing you to manage this at the kind of lowest level, or pass it up or whatever. It was just one of the mistakes that were made in Java as we were learning.
Yeah.
So it's, at least I understand the model now, because before I was putting in my own succeed or fail, which you can do very nicely in Kotlin.
Yep.
And they're,
yep. Yeah. I was surprised diving in that they didn't have a success kind of trait or abstract class, and or that would be a what Scala calls an either.
Mm-hmm.
And then, or a try is a type of either that can either succeed or fail.
Right.
And I was surprised that there wasn't one in the Kotlin standard library, but Roman's blog helped to understand why they have a different way of thinking about that.
Right. And it was comforting to know that, because I was wondering the same thing. Why don't you do this? This is nicer. But it was intentional. They thought about it and they said, for reasons, we're going to do it this way. It's better than the Java way. It's not as good as returning, intentional objects. But it is like, yes, this is the model that we're going with. So at least I know what's happening now. Yeah.
I want to save coroutines for last. So I was trying to think about some of the other syntax things that I like in Kotlin, or that have been interesting.
I like the attention to simplicity and clarity, because they don't do, they look at how are things going to be used in general. And so, like, if you create a class, you can't inherit from that class unless you say the class is open. And if I'm going to override this function, I have to make that open. And so it kind of forces you to say, yes, I'm going to be doing these things with this thing. And I like that. And how minimal you can make your code if you want. You can say class bear, no semicolon. The lack of semicolons, I got to say, I don't even think about that anymore unless I'm working with the semicolon language. And then it's like, why are you making me do this? I just feel like it's, lazy compiler writers.
Type inference along those lines. Like,
type inference.
It's something I almost forget about, because it just seems like, of course, every modern language has type inference. But Kotlin did a great job with that. And it's interesting to note how at least my perception is that the ordering of things, the way, because if you look at C, it, gives the return type first, and then, and it doesn't have an explicit function. Or var or val. And when you see, if you have those things, it allows it to do this much cleaner syntax and type inference and stuff. I don't think there is languages that are doing type inference well that don't put the type information on the right-hand side.
Right.
So that's kind of converging to a standard around type inference.
Right.
Parameters on the right side.
The stuff that they added to Python, the optional typing, is the right-hand side stuff, obviously. And
speaking of val, the immutability stuff is pretty good in Kotlin. It feels pretty natural, and it's not as much as it is in Scala, where in Scala it feels really nasty to do immutability. So it's not that far. But at least most stuff in Kotlin really, I think, tries to be immutable with vals. And so I think that's good. There still is in Kotlin, I've seen quite a bit of like builder pattern stuff, which mutable builder pattern, I just think should die. But
well, because they have they have the, where you have the lambda. And that you don't like that.
If it's mutating, no, it just gets...
It's mutating within the thing, but once the thing is done, it's immutable.
Yeah.
So what's your objection to that?
There's things that are not expressed in that case that get really hard to grok. So what I've seen happen in some of those cases is that there is a necessary ordering in the builder that you have to do you have to do your builder kind of pieces sometimes in a certain order, so that the thing that is doing some mutation of something requires the presence of some other thing, but that's not actually expressed in any way. And so then you get weird errors where you try to like do something in the builder that's doing some mutation underneath the covers. So yeah, just the whole mutable builder pattern. I've just run into too many places where I can't logically understand why something needs to be the way that it needs to be. It's not expressed in the type system or in the language construct. So,
well, because we had in the book, we had an explanation of how I think our example was a somewhat complex initialization of say a two-dimensional map or something, and went through doing it in the functional way, and it was complicated. And so they've added some kind of map builder or whatever, which is the thing that you're talking about, and it's like so much simpler to think about, at least at this level. Now what you're talking about sounds like it's maybe more sophisticated, but ended up taking the section of doing it the proper functional way out, because it was just a little too overwhelming.
Too cumbersome.
Probably turn that into a blog post or something.
I think the language needs to have certain things that it does to help you avoid mutable builder patterns, and Scala I think does a good job of that. But Kotlin I've seen where maybe due to some language constraints they just kind of punt in some cases and say, just do a mutable builder. It's easier.
Okay.
So builders should die, but we can't kill them yet.
I think those are being created at this point. So because I know that version 1.4, I believe, added this thing that I was talking about.
I'll check that.
So you can look at it and see if it's still offensive to you. And then there's so many things that they cleaned up from using Java. Just
nice.
Having to put classes in a single file in this weird all that's gone.
Nice.
And it's like, it's just, I want to do this thing, and the language isn't pushing back saying, we have rules and everything's got to be an object. Well, there's a huge thing for you right there. It's like you can have functions, and you're not forced into this object thinking model, which was where I started, but now I've come around to there's some people who go, now all objects are bad. And I'm going, no, sometimes objects are useful. The problem was having the idea that everything should be an object forced on you. That was a poor choice, because and I've had this experience with Python where I start writing my program and just using functions and things, and then something doesn't feel right, and it doesn't feel right, and I go, that thing wants to be an object, but it's more of a special case than the general case. So I think
it's nice that Kotlin lets you structure things what feels natural, and then you can easily move things around as you discover how things should be structured. Hey there, this is James. As this was our first podcast, of course, we had some technical difficulties, and my computer went to sleep. And so we talked for about another half an hour before we realized that. We've learned some things, and so we will continue this conversation on episode 2. Thanks for listening.